All right, peeps, I'm back with the circle problem. Let's draw this thing. I'm still trying to find, I have this circumference here of this circle, and if I assume that I can measure the diameter, I'm going to assert that the circumference is proportional to the diameter, which means that the circumference is equal to the diameter times some constant, let's call it k. And I want to determine what this constant is. And I think if I know what this constant is, no matter what size the circle is, if I measure the diameter, I can determine the circumference. So someone on Facebook said, well, it's pi, it's 3.1459. And that's nice. I mean, I wonder how, I don't know, how do you know that? So I think that's a major problem with how math is taught these days, is that someone told you this number is 3. How do you know that's the case? How can you prove that's the case? Archimedes looked at this problem in 200 BC, and he was trying to figure out what this constant was. What did he try to do? What did he come up with? So I want to look at this problem, not just saying, well, pi is 3.1459. That might be the case. Let's see how or why that's the case. So one way we can solve this problem, what Archimedes did is he approached this by inscribing shapes inside this circle. So we need to find out what this C is. That's the key thing. So how do we do that analytically? Like, we can't measure it. If you try to measure it physically, like with a string, there's always going to be errors in your measurement. You're not going to get this number, this theoretical number pi. So what we need to do is do it analytically. So we're going to assume that, I'm going to set this problem up to assume this D is 1. So this is a circle with diameter 1. And then we're going to inscribe, and this isn't me who did this is Archimedes, but let's just follow along with his method. He's going to inscribe a square inside this circle. Not a perfect drawing. And he's going to circumscribe a square, which means he's going to draw a square on the outside. Yeah. So now it looks like this. So to determine this K, what we need to do, K is going to equal this. We can measure the diameter. We know what the diameter is. I said it's 1. We need to determine what this C is. How are we going to do that analytically in this math world here? What we're going to do is, what Archimedes did is, he's going to approximate C. He knows that C has to be in between the perimeter of this triangle. It's going to be less than the perimeter of this triangle and greater than the perimeter of this triangle. That's what C is going to be. So he didn't find pi explicitly. He said pi has to be between these two values. So I want to do this. I want to leave this problem open, and I want someone to go through the geometry and tell me the two values that C is going to be between here. So C is going to be, there's going to be some maximum, a maximum value and a minimum value. Let's find these out. Post, and let's get into it. Thanks. Have happy Thanksgiving. See ya.